Okay, so when you want to do this one, you're going to go to your well, you can't really solve it um, without using your tables. I think. Well, I mean, I probably could, but I'm going to use my tables. So I'm going to go to y equals. I'm going to type 9 raised to the x minus 243. And I'm looking to when I get my 0. So I'm going to go look and see when y is 0, see if I can figure it out. And I can't. Okay, so it's somewhere in there. Let me hit graph and see what happens. It's right there. Okay, so let's try this. Put in when this equation hits 0. Oh, 0. Wow. Okay, hit second, catalog, intersect. Every time you want to do that, hit first curve, second curve. My guess is, well, I'll say 2. It's actually 2.5. So my answer is 2.5. Wow, well, my tablet's having some issues. 2.5. How could you do this otherwise? You could, you could do the inverse. So if you had y is equal to 9x 243, you could do the inverse, which is the log. Okay, so you would do, you basically change this over. So this would be log 9. This would become, let's see, I wrote log x even though I said 9, which is very confusing. Hold on a second. Okay, so let me go back and talk about that again. So if I wanted to do the inverse so that you can have control over it, because right now what they're asking you is this. They're asking you when does this equal 0. That's what they want. Oh my lord. That's what they want to know. They want to know 5x minus 243. When 9 to what power gives you 243? So if you bring this over, 243 equals 9x. You can put in the calculator, swap the, rewrite it. So you're going to have log 9 of 243 equals x. So basically, and then you're looking when you're trying to figure out when this is 243. So basically, I want to know. So if I go and look up my calculator, I should be able to type in log 243. Why is this so many problems? Over log 9 should give me that answer. So let's see if I can get my calculator up and moving again, maybe. Nope, not working. Let's see if I can get this thing up and running again. Okay, so I put in, I can just go to my home screen at this point. Log 243 divided by log 9, 2.5. Okay, you can do it that way if you want. That's probably the best bet if you changed it into logs. And all I did was, again, the log change is you do a to the b equals c. So log of little a to the c equals b. That's a conversion. That's changing it from type to type. Okay, alright, I'm going to keep going before this computer completely dies on me. Alright, this one, it says which one belongs to the same family. Alright, the deal on this one is, notice that a normal one that we've seen, parent graph we've seen before, usually has one of these branches in one quadrant and then one in like the diagonal quadrant. like either it's here and up here, or it's up here and down there. Because they're next to each other, what that leads me to believe is that every time I put a y, no matter if I put in a negative x or a positive x, I'm still coming up with the same y's. So to me, if I'm squaring x, I'm making negatives into positives, then this one and this one make total sense on the ones that would fit into the same family as this one. Okay, this guy has to do with asymptote at -1. This doesn't have it. This one has an asymptote of 0. That's true, but again, if you were to put that in, you wouldn't see these two graphs. You'd see one here and then one diagonally. So the x squared is what makes the x's, the negative x's, and the positive x's be basically behave exactly the same. Oh, the solution set. Okay, so if I were doing this one, Mr. Watley would do what? Right, if you watch the beginning of the videos, you know I'm going to get this into y equals. So again, my rule of thumb is if it's on the wrong side, then do its opposite. So I'm going to put an equal sign here. This will be -5x. This will be positive 11. I've got a -4y. So I'm going to divide. So y equals, and I'm going to put this in parentheses because I don't feel like doing it myself. My tablet is really hurting right now. I'm not quite sure why. It's not wanting to do everything I want it to do. Alright, so it's kind of getting glitchy. And then, so I have that. I'm going to put that in the calculator, and then I'm going to put this one in the calculator, which is already set up. You should be able to tell me exactly what these things are. That's a line, and that's a quadratic. So I could have at most 2 answers. I could have 2 answers because the line could hit through the quadratic 2 times. So I could have 2 answers. Alright, so I'm going to put those in the calculator and see what happens. Let me get that calculator up. Okay, so I've got the calculator up. I've got the equations popped in there, so you can see I just put in y, the one y I got, second y, and I hit graph. And sure enough, there's my quadratic, and there's my line, just what I thought what would happen. Now, again, to do this, do you want to figure out what both of these x values are? Now, you can almost eyeball it. That looks like -1, and then that one looks like it's -3. So, or even +3, or even +2, or positive. No, I would probably, if I had to guess, I would guess this one right here, and I would guess, what was the other one, -1? I would guess those two. But we're going to, hopefully, if I didn't lose it. Alright, so what I'm going to do is I'm going to use that second calculate, intersect, and I'm going to just try them out to make sure they work. Okay, first curve, second curve. Now I'm going to guess. Again, my guess is negative. Ooh, actually that looks like -2. Let's scratch that. We'll pick -2 in a second. So let me pick -2 and see if I'm right. Nope, -1. So there I go, -1's one of my answers. Oh yeah, intersections, that's right, -1. And then I wanted to see if 3.25. So I'll hit second, calculate. I'm going to go over to intersect. I'm going to pick first curve, second curve. Again, it doesn't really matter at this point until you guess, and your guess is about 3 maybe. So it knows which one you want to look at, and 3.25. There it is. And I can see my 2 points of intersection, so I know those are the only 2 answers. So that was not too bad at all. Alright, factoring, that's least people's favorite, but here's the deal. When first thing you look for is GCF. This ends in a 5, this one doesn't, so I'm not going to be able to do anything. But this cube should give you an indication of how to factor this. If it doesn't, then you need to really seriously go back and look at that factoring. Cube is supposed to help you with the cube, knowing that it's the sum or difference of cubes. So what you're going to do, whoops, I don't want to tell you what the answer is yet, but basically you have cube. So you need to figure out what things are being cubed. So when you use your calculator, I don't think mine's still up anymore. Maybe it is. So let's see if it's still working for me. Is it? Oh, good. It's still working for me. I can go to my math key and pick number 4 right here. Pick number 4 and actually type in 125. And it's going to give me 5. So I know that one of my terms is 5m. And then my other one, let's make that into a better looking 3. we're going to go back and hopefully my calculator is still working. Yes, it is. I'm going to hit math number 4 again, and then I'm going to type in 343 and see what I get out of it. And this is a 7. Okay, so now these two are the two things that, if you notice, is no surprise. Look, there's the 5 and there's a 7. So which one is it? Alright, so how are you going to do this pattern? This is the thing you have to have memorized at this point. You have to have it memorized in order to get this right. Okay, so 5m minus 7. It's called same, opposite, plus, or always plus. Some people know it as SOAP or SOP. So that's same, opposite, always positive. That's what that stands for. Alright, so that means my sign's going to be opposite of what I had, and then this one's always positive. So now I have to figure out what terms go in here. First of all, I can look at my choices. I already know this is out. And let's see, these two are okay, and this one is definitely out. So I've got B or C as a choice. So this is what you do. You square this first term. So square that, you're going to get 25m squared. Then you're going to square this one, which gives you the 49. Alright, so here's the key. Multiply these two together. That's where the key is. 35m. Which is exactly what that is right there. So that's the choice, choice B. Alright, what problem am I? 19? Alright, I'm stopping at 20 because I need a break. Alright, so the last thing I'm going to do here is cube roots, and that's actually a little bit of work, but basically what I want to do is I do the factor tree with my kids. So 27, if you want to list all those out, you could, but there's 27 of these p's. There's 8 of those, and so 576 is working with, and then the index number means I'm trying to take out groups of that. So I'm going to work with the 576 first. So I'm going to break this up. 576. What can I break that up? Let me bring out my calculator. Maybe it's still running. No, it's not. Okay, so let me bring out my regular calculator. We'll use the cheapy cheesy. Alright, 576. Let's divide it by 2 just to see where we're at. Okay, 2 and 288. If I break up 288, I can break up 2 and 144. If I break up 144, I'm going to get 12 and my tablet is getting tired, I think. 12 breaks up into 2 and 6. 6 breaks up into 2 and 3. And I got the same thing going on over here. Okay? That's all broken out. Now, I'm looking for groups. Let me change color here. I'm looking for groups of 3. So, here we go. We got 1, 2, 3, group of 3. Okay, then I've got 1, 2, 3 groups of 3. Okay, and then that's it. So I've got 2 groups. So every time you circle a group, you put their number down. So I have 2 2s. Group of 2 and another group of 2. Alright, now I'm thinking about my letters. This means I have, just to let you know, I have 1, 2, 3, 4, 5, 6, 7, 8 of them. If I do groups of 3, I'm going to have 1 group, 2 groups, and then some leftovers. So every time I underlined a group here, or circled a group, I write their letter down, just like I was writing the numbers down. I've got 2 groups, and then I've got this junk that's left over. So anything left over, I put back in the radical. So here's my 3. I've got 2 3s, that's 9. And then I've got, let's see, I've got 2 n's, so that's n squared. And then 27, I can get 9 groups. So this one's going to be P9, because I can get 9 groups of 3 to get my 27. So what do I have here? I have 4n squared P9 cube root of 9n squared. Looks like that's the first one. Whew! Alright, I'm stopping at 20 and I'll do another video shortly.